Hi guys and welcome back to the ACE Academy. In this video, we will be focusing on a summary and a bit of revision for your grade 10 functions. Now, the purpose of this video is not for me to teach any new theory. We're just going to go ahead and revise the topics that you have already learned up until this point. It's just to give you guys a bit of an overview and a recap so that you are a bit comfortable with knowing that you know your theory. So you can use this video as a revision purposes in grade 10. You can use it to refer back to your grade 10 functions once you progress to grade 11 and grade 12 functions, because this section is progressive, meaning that the things that you will learn in grade 10 carries over to grade 11 and grade 12 and so on once you enter university. So you need to always have a strong reference for this section. So on your screen right now, you guys can see a list of information, and I'm just going to go ahead and explain that quickly. We know that in grade 10, you guys learn 4 types of functions, and that would be your linear function, the parabolic function, the hyperbolic function, and the exponential function. And these functions have set shapes. When I'm speaking about a set shape, I want you guys to think of how the function would exist without any manipulations to it. So for each one of these functions, you would get something called a natural function, and that is how the function would exist in nature without any vertical manipulations, horizontal manipulations, changes in shape, and stuff like that. It's just how it exists in nature, and using that, you would be able to understand the characteristics of each function. Now, for these functions, you would have a standard equation, which would allow you to understand, quantify, and mathematicize the manipulations applied to each function. For example, for a change in shape for a linear function, we would manipulate its gradient, the mx part of the formula, right? For a vertical shift, we would manipulate the q value, because that would either tell us whether it is a vertical shift moving upwards or a vertical shift moving downwards. And that's basically the information that the standard equation would give you, and it would allow you to define a function mathematically. Another important point for each function would be its x and y intercepts, because x and y intercepts are important points for this function. It allows you to visually see the shape of the function, right? Changes in shape can be applied using, for example, for the linear function, you'd use the m value. For the parabolic and hyperbolic function, you'd use the a value. For the exponential function, it'll be a combination of your a and b value. And of course, you'd have your domain and range, which will tell you for which x values a function will exist in terms of domain, and in terms of range, it'll tell you for which y values this function will exist. That's important. So let's go ahead and do a bit of revision with regards to these functions. So guys, looking at the linear function, you would notice that the natural linear function has the equation y is equal to x, and that's how a linear function would exist without any changes in shape or vertical manipulations, right? The standard equation for a linear function would be y is equal to mx plus q, where m is actually your change in gradient, your change in shape rather, and that can be calculated using your gradient formula. M is equal to y2 minus y1 over x2 minus x1. That's if you have two known points on this function, you would be able to calculate your m value. You could also substitute in a known point as long as you know your y-intercept, and you'd be able to manipulate out to find the m value. In terms of domain and range for the linear function, the linear function will always have a domain of x is an element of real numbers, and y, it would have a range of y is an element of real numbers, meaning it will always exist for each point that is there on your Cartesian plane. It will continue to infinity. Another way to write this would be to say x is greater than negative infinity and x is less than positive infinity. And for your range, it would be y is greater than negative infinity and y is less than positive infinity. Essentially, when it comes to writing domain and range in this format, which is an inequality format, it is extremely important that you start with the lowest number and progress on to the highest number. You don't want to write it as x is less than infinity and x is greater than negative infinity. You want to write it in this format because this is the only acceptable format in the inequality form. Otherwise, to write it on the safe side, you could say x is an element of R and y is an element of R. That is the simplest function that you guys would do, and it is the linear function. Moving on, if we are looking at the parabolic function, the natural parabolic function has the shape as sketched on the screen right now, and it has the equation y is equal to x squared. This is how this function would look without any changes in shape or manipulations to its y-intercept, or vertical manipulations rather. In order to understand this function well, you would need the standard equation, which is y is equal to ax squared plus q, where a is a manipulation of shape and that q value is the value of your y-intercept, and it will tell you how the function has been shifted. If it's shifted upwards, you would have a positive q value. If it's shifted downwards, you would have a negative q value. And that's just because if we add something to each point will get higher or greater proportionally. If we subtract something from each point would get lower or lesser proportionally, right? That's how we would manipulate the vertical shift of this parabolic function. For the domain and the range of the parabolic function, let's look at domain first, guys. Domain is the x values for which this function would exist. Now we can see, looking at this function, that it would exist for all the x values because of these arrows right here. It tells you it continues to infinity. So for domain, we can simply say x is an element of R, or we could say x is greater than negative infinity and x is less than positive infinity. Now, in terms of range, the parabolic function is a bit different. Can you guys see the turning point right here? Now, this turning point is important because the function will never go beneath this turning point if it is positive. It's a smiley face parabola, which means the range in this case would start off at 0. So we would say y is an element of, we'd start off with square brackets because 0 is included, 0, comma, infinity, because it would continue to infinity, and we close off the infinity with a round bracket because it is not inclusive. You can't contain infinity, right? Another way to write this is you could say y is greater than or equal to 0 but less than infinity, right? It's quite simple, guys. Now, if we were to look at what would happen if we manipulated the a value to be negative, we would end up with a sad face parabola that would look something like this. Now, in this case, you can see that the parabola has a maximum instead of a minimum, meaning its turning point will be the maximum value for its range. So in this case, its range would be y is an element of negative infinity to 0, because it would continue to negative infinity, but it will never pass that 0 point. It turns at the 0 point. Can you guys see that? It's important. It's quite important. Now, if I am looking at a manipulation of shape in terms of a fraction and a whole number, if I change my a to any value that is greater than 1, this function would become skinnier. It would not be as wide as it is right now. But if it was a fraction, if my a value was a fraction, the function would become wider. Now, with regards to finding your x-intercepts and sketching the function as well as finding the equation of the function, I urge you guys to go back and watch the video where I cover this in detail. I will try to put the link in the description, right? But it's quite simple, guys. Okay, moving on. We are now looking at the hyperbolic function. Now, the natural hyperbolic function, speaking about the hyperbolic function that does not have any manipulations applied to it, it's just how it exists in nature. will have the equation of y is equal to 1 over x. And this function will exist in the first and third quadrants. It would have a horizontal asymptote at y is equal to 0, and it would have a vertical asymptote at x is equal to 0. Meaning your horizontal and vertical asymptotes would be your x-axis and your y-axis respectively, right? In order to obtain a change in shape for this function, you would manipulate its a value, and the change in shape for this function is relatively simple. It is just a matter of changing the quadrants of that the function exists. So if the function has a positive a value, a positive numerator, it would exist in the first and third quadrant. But if the function has a negative numerator, it would exist in the second and fourth quadrant. Just for you guys to see it visually, I'm going to draw it in. So if my a value was negative, it would take the shape of the blue function on your Cartesian plane. Now, for the vertical shift of this function, it would manipulate your horizontal asymptote. So your q value would be a manipulation of your horizontal asymptote and a vertical shift. If I have a +2, for example, my horizontal asymptote will now be at +2 instead, meaning my entire function has moved up 2 units. If it was -3, this entire function would move down to -3. The horizontal asymptote would move down to -3, meaning that each point on this function would move down by 3 units. It's quite simple. Your q value gives you your horizontal asymptote, right, guys? For the domain and the range of this function, domain being all the x values for which this function would exist, it would be x is an element of real numbers, but x will not equal to 0. Why? Because when x is equal to 0, we have a vertical asymptote. We won't get a value. It doesn't make sense. 1 divided by 0 is undefined. Get it? So that's the reason why it would be x is an element of real numbers, meaning it would have a value from -infinity to 0 and from 0 to +infinity, but at 0 itself it wouldn't have a value. So the way that we would write this is x is greater than -infinity, x is less than 0, and x is greater than 0, but x is less than +infinity. So these are two ways in order to write your domain for this function. The first is quite simple. The second is also quite simple. It allows you to see it visually. Just use whichever one that you prefer. You'd get it right anyway. Looking at your range is all the y values for which this function will exist. Your range would be y is an element of R, because from -infinity to +infinity you will have a range, except when y equals to 0. So y will not equal to 0. Get it? So your range would be y is an element of R and y does not equal to 0. In order to write it in expanded notation in inequality form, you can say that y is greater than -infinity and less than 0, and y is less than +infinity but greater than 0. It's quite simple. If you see it visually, you'll understand it well, right, guys? For details on how to sketch this function and how to obtain an equation from a given function, I encourage you guys to go back and watch my video on that. I will put the link in the description for that as well. Okay, guys, now for the final function, the exponential function. Okay, I explained this to you guys in my video on exponential functions, that we don't study the natural exponential function because you guys don't use this in grade 10, 11, and 12, but you would use it if you are going into a STEM field like engineering or medicine and stuff like that. So I don't want you guys to worry about the natural exponential function. It's a bit of a doozy, but I'm going to teach it to you guys a bit differently. We know that the standard form for an unshifted exponential function is y is equal to a times b to the power x. Right. In this equation, the combination of a and b will give you the shape of the function, right? And I'll explain that in a bit. but I do have a video that goes over this in detail. The Q value in your standard equation is the value of your horizontal asymptote. Naturally, if it is unshifted, meaning if it does not have a vertical shift, your horizontal asymptote would lie at an equation of y is equal to 0. Now, this function does not have a vertical asymptote, but it does have a y-intercept at y is equal to 1. Okay, so x is equal to 0, y is equal to 1, that would be its y-intercept, and that is just because if you have any number for a value of b, let's look at 5 for example, and if my x value is 0, so I would get y is equal to 5 to the power 0, and 5 to the power 0 is 1. Let's look at 100 for example. 100 to the power 0 is 1. So any b value when raised to the power of 0 would give you a value of 1. Okay? Another important point that I explained to you guys is that your b value will never be negative. If you have a negative value associated with your exponential function, that negative sign would be assigned to your a value. Your a value is usually either positive 1 or negative 1. If it is positive 2 or negative 2, for example, your every value would be multiplied by that number. So where previously your y-intercept would have been at 1, if my a value is 2, my y-intercept will now be 2. 0 and 2. Get it? You guys can go ahead and watch my video where I explain that in detail. But it is relatively simple. Looking at your a and b values for shape, right? I explained this quite a bit in my shape manipulation video for the exponential function, but essentially you would get 4 types of shape for this function. When a is positive, your function would lie above its horizontal asymptote. When a is negative, your function would lie beneath its horizontal asymptote, right guys? So it would take a shape that would look like this, okay? Now, when I'm looking at a function like this, my b value is greater than 1, right? I mean, I'm looking at a function that looks like this, my b value is greater than 1. But what if my b value was a fraction? Essentially, all we would be doing is, say if a was positive and b was a fraction, say a half, right? Because a is positive, it would lie above my horizontal asymptote, and because it is a fraction, it would now start away from my horizontal asymptote and progress towards it, right? So it would look something like this. But what if my b value was negative? What if my a value was negative rather? If my a value was negative and my b value was a fraction, it would still start off away from my asymptote, my horizontal asymptote. It would be beneath the horizontal asymptote and it'll progress towards the horizontal asymptote. So it would look something like this. It's actually quite simple, guys. So if you guys need any more details in terms of any aspect of functions, I have covered each one of these aspects in a single video for you guys to go back and refer to. They're not long, they're probably about 5 minutes each. When I'm looking at the domain of the exponential function, it would have a domain of x is an element of real numbers, because the function exists for any value of x, right? This can also be written as x is greater than negative infinity and x is less than positive infinity, right? For range of this function, this would be entirely dependent on your shape. If a is positive, so if a is greater than 0, your range would be y is greater than 0 but less than positive infinity, right? But if a is negative, meaning a is less than 0, your range would be y is greater than negative infinity but less than 0. It's quite simple. Anyway guys, that is it from me. All the best, and I will see you in the next one.